All right. Hi, my name is Marta Hatzell, and I'm assistant professor in mechanical engineering at Georgia Tech. And so when I started my faculty position at Georgia Tech, I came with a background in water treatment and electrochemistry. And so what I decided, we have a unique opportunity as faculty members to really, formulate a vision that we get to propagate over hopefully a career. And so what I started with my research group was trying to answer a why that has been really well established by our prior speakers, which is how can we basically create more renewable food, energy, and water? And how my group tries to address this is by using these renewable electrons that we see are growing in our infrastructure to upconvert these electrons into more valuable products. So we start out with this proposition that we are increasing the renewables in the electric grid, which is great, but that they are occurring in an intermittent fashion. And so we need to store that electrons. And we can store those electrons in simple, bonds in batteries, or we could upconvert them to valuable products. And as the previous speakers mentioned, if electricity gets down to 1 cent per kilowatt hour or 3 cents per kilowatt hour, what it would be valuable to upconvert it to something that's worth more than 1 cent per kilowatt hour or 3 cents per kilowatt hour. And what we believe is worth more than 1 cent per kilowatt hour and 3 cents per kilowatt hour is water and food. And so my research group focuses on, right now, 3 projects, one in the energy space, one in the water space, and one in the food space. So I'll just briefly give you a few sentences about all these 3 projects. Within the water space, there's a growing need to desalinate water, especially if you live in coastal regions such as in California. What happens when we desalinate water is we remove everything from the water, we get a really pure water, and then what do? We add salt, actually, back to our water, which is counterintuitive. Because if you want to desalinate water in an energy efficient way, that's not very energy efficient. So there is this growing need with desalination to minimize what we remove from water so that we can actually desalinate in a truly energy efficient way. And so we are working on using electrochemistry to develop selective separations. Maybe we can keep some of the sodium in the water rather than removing it. Selective separations could also be helpful for desalination downstream. We create these brines that we end up just discharging into the ocean, or we send them deep down into geological wells. Those brines are rich with minerals, nutrients, metals that we potentially could recover. And so electrochemistry may be a means to start recovering that lithium that we're just wasting away, or recovering those nutrients like potassium or phosphorus that we're just discharging. So we're working in the area of selective separations, specifically with respect to aqueous environments. The second approach that we're looking at, which is in the food direction, is how do we make nutrients in a more distributed fashion? As we mentioned with grid energy storage and our infrastructure challenges, changing infrastructure in the United States is slow. Can we potentially, instead of looking at developing these nutrients in a very centralized way, can we make these nutrients in a very decentralized way, perhaps even on a farm site? And what we're actually proposing, and we're working with A.J. Medford in chemical engineering, is perhaps we could use solar energy to directly make those nutrients like ammonia on a plant using only solar, water, and air. And so we're using photocatalysis as a means to accomplish that goal. And then the third project that we're working on is related to energy storage. So we will need to increase our energy storage to deal with this renewable energy on the grid. And we actually have lots of different battery chemistries that we know how to make, or we can test at very small scales in our lab. The challenge with translating batteries to application actually is in the manufacturing of those batteries. So we have a third project actually with Tequila Harris in mechanical engineering to actually look at how do we scale roll-to-roll manufacturing up of these batteries for grid energy storage. And the challenge is actually not in the materials not in the chemistry, but actually in the manufacturing. So these are 3 different problems that we're working on in my group, which really use electrochemistry as its fundamentals, but are trying to deal with this idea of how do we store renewable energy in valuable products, whether they are water, energy, or food. And with that, I'll be happy to answer questions after this event.